You know, some numbers look totally normal, but if you look a little closer, you can find these incredible, almost magical patterns hidden right inside them. Today, we're going to unlock the secrets of a few of these mathematical curiosities.
All right, let's just dive right in with our first mystery guest. Take a look at this number, 142857. I mean, at first glance, it doesn't look like much, right? Just a string of digits. But just wait, watch what happens when we start to play with it.
So as we multiply our number by 1, then 2, then 3, all the way up to 6, look closely. It's the exact same digits every single time. They're just shifting around in a perfect circle, like they're all on a Ferris wheel together. But what if we multiply by 7? You get 999,999. Whoa, that's a whole different kind of magic trick.
And it's not the only number with a secret identity. Let's bring in our next character, 1729. This one looks even more ordinary, but it is hiding a completely different kind of secret. We're going to come back to this little imposter later, but for now, seeing these numbers just raises a huge question.
So, what is going on here? Are these just delightful little flukes in the world of math? Or are they actually clues, pointing to some kind of hidden structure that governs how all numbers work? Well, to figure that out, we need to find our first key.
To crack these codes, we need a key. And that key, believe it or not, is the number 9. Understanding its really special property is the first step to solving both of our puzzles.
The concept we need is something called the digital root. Now that sounds complicated, but I promise it's incredibly simple. You just take any number, add up all its digits, and if you get a number that has more than one digit, you just do it again. You keep going until you're left with just one single digit. Let's see it in action.
Okay, let's just grab a random number here. How about 15,876?
So, first step, we just add up the digits, and that gives us 27. Since that's still 2 digits, we've got to go one more time.
So we take that 27, add 2 plus 7, and boom, we get 9. That's the digital root. But why does this work? Is it just some neat trick? No, it is not a trick at all. It's actually a result of something called modular arithmetic. The easiest way to think about it is clock math. You know how on a clock the numbers wrap around after 12? Well, in our number system, the digits basically do the same thing, but they wrap around after 9. This means any number you can think of, when divided by 9, will have the exact same remainder as its digital root. That's the secret. All right, so now we're armed with our new tool. Let's go back to our first mystery, that endless circle of digits in 142,857, and see how this all connects.
So, there's actually an official name for a number like this. It's called a cyclic number, and they aren't random at all. They come from a very specific place. They're the repeating digits you get when you divide 1 by certain prime numbers.
And here's the big reveal. If you punch 1 divided by 7 into a calculator, you get 0.142857 repeating forever. There it is, our magic number. It's generated by the prime number 7, and its cycle is 6 digits long, which is the absolute maximum possible for that prime. And that's what makes it a perfect cyclic number.
And just to show you this isn't some one-off fluke, get a load of this beast. This is the 16-digit cyclic number you get from dividing 1 by the prime number 17. Yeah. If you were to multiply this huge number by 1, 2, 3, all the way up to 16, you would see that same incredible, mind-bending circular pattern. It's a fundamental property of these special prime numbers.
Okay, so we've solved one mystery. But what about 1729? Its secret isn't about cycles, it's about pure deception. This is a number that pretends to be something it's not. It's an imposter.
So, 1729 is the smallest example of what's known as a Carmichael number. Now, the technical definition is a bit of a mouthful, but the key idea is really simple. See, there are certain math tests you can run to check if a number is prime. Carmichael numbers are special because they are not prime, but they're so sneaky they can actually pass some of these tests anyway. They are, in short, fake primes.
So what's the difference? Well, a true prime number passes those tests because it really is prime. You can't factor it into smaller whole numbers. But a Carmichael number, like 1729, it fools the test while hiding a big secret. It can be factored. As you can see, it's actually 7 times 13 times 19. It's a composite number wearing a very, very clever disguise.
So how on earth does it pull off this trick?
Well, it works because of a beautiful, almost unbelievable mathematical coincidence. To fool the test, the number 1729 has this really special relationship with its own prime factors, 7, 13, and 19. It's a very specific alignment that basically lets it cheat the test. It is the perfect mathematical imposter.
Okay, so we've explored some fascinating patterns and some really clever imposters. But these are not just mathematical toys. They actually have these profound, powerful applications in our world today. Let's see how this all builds to something incredibly important.
So why does any of this matter outside of a math class? Well, because these ideas are literally everywhere. In cryptography, we have to find enormous prime numbers to keep our data secure. That means our security systems rely on tests that are strong enough to spot imposters like Carmichael numbers. That idea of digital roots, it's used in things called checksums to make sure your data hasn't been corrupted. And those long, beautiful cyclic numbers, they're used to generate predictable, random-like sequences for all kinds of computer simulations.
These aren't just curiosities. They are the absolute bedrock of our digital world. The hunt for true primes and the need to unmask these imposters, that has become the system of locks and keys that protects our entire online lives.
We've unraveled the secrets of a couple of really special numbers today. But the world of mathematics is just this infinite ocean of mysteries. For instance, we know that the number made up of 19 ones all in a row is prime. It's called a repunit prime. But what about the number made of 23 ones or 317 ones? Are there infinitely many of these repunit primes out there? The amazing answer is nobody knows. It's one of the great unsolved questions just waiting for the next curious mind to come along and explore.